So do you want to start with a quick introduction about yourself, who you are, where you went to school, undergrad, grad, and then doctorate and even postdoc, and then where you are at right now?
So I grew up on the East Coast. I went to high school in California when my father was transferred there. I was an undergraduate at UC Davis. I started pre-law, but ended up transferring into engineering. I majored in chemical engineering and found it was a good match for me. I liked chemistry. I liked math. I went to do my PhD at the California Institute of Technology, Caltech, in chemical engineering. During my undergraduate years, I spent a couple summers working in industry, in a lab, in an oil field, just different things like that. My PhD involved experimental work and some theoretical and numerical work in what's called fluid mechanics, which studies the flow of fluids. I then did a postdoc for a year at the University of Cambridge in England in what's called the Department of Applied Math and Theoretical Physics. Then was lucky enough to get a faculty position at Harvard in engineering. They have a small engineering school. I stayed there for 20 years, and 15 years ago, I moved to Princeton, where I'm a professor in the Department of Mechanical and Aerospace Engineering.
Oh wow, that's amazing. Yeah, can I ask what prompted that shift from pre-law to STEM?
Well, what I remember and what I say when I'm asked is I always liked reading. I always liked history. I had never had physics in high school, and I had watched a lot of television, including television shows involving lawyers, and that sounded interesting to me, intellectually interesting. But when I was a freshman at UC Davis, I needed a class, and everyone in the dorm was taking beginning chemistry because many of them were pre-medical students. And so I took a chemistry class. And the professor was the first, what I think I would say is it was the first time I ever understood what someone was trying to explain to me about how science worked. He's no longer alive. His name was Dino Tinti, but in that sense, he changed my trajectory because he opened my eyes to what it meant to understand the world you live in through science concepts. And my father was an engineer, and he kept encouraging me to take an engineering class. And so I sort of did that the next quarter, and then didn't quite know what to do, but I sort of liked a little of both. And so I decided, well, chemistry and engineering, maybe that means chemical engineering. Of course, it doesn't quite, but that was another story. And anyway, so I ended up in
Yeah.
chemical engineering, and UC Davis had a magnificent chemical engineering department.
That's really cool. My dad's an engineer too, and he keeps trying to push me down that path, but not really interested.
I will change your mind about this with one story.
Okay, let's hear it.
What's the origin of the word engineer? What would you guess based on the way it's spelled?
Engine, like a car engine.
Do you speak French or Spanish?
I'm learning French.
Do you know how you say engineer in French?
Ingénieur? I
Yeah,
don't know.
it's ingénieur. How do you spell it? You
With an
spell it
I?
with an I. Yeah, you're doing great. It's yeah. So now think the following. The word derives from the Latin, and it's
Like
ingenuity.
the
It is
yeah.
only subject label at a university or department name that derives from the word creativity.
Yeah, do you mind explaining a little bit about your own research, in terms that are more understandable to a high schooler?
So I study a subject that involves liquids and gases, how they move, their what you'd call their dynamics. And that involves many things in the world. It could involve how airplanes fly. It could apply to how the space shuttle re-enters the atmosphere. It could apply to how birds fly or how fish swim. Those are all problems involving motions in fluid materials, whether those are liquids or gases. But my specific interests tend to be more small scale. By that, I mean how blood cells move through blood vessels, how bacteria swim in biological fluids, how materials in living systems, whether they're cells or tissues or molten polymers that you might use in manufacturing, how those flow. So those are my specific interests. There tend to be smaller scale systems. They tend to not be what you'd call one phase. They tend to have things in them. And the research problems we do, which tend to be somewhat fundamental, are inspired by real problems, whether those are industrial problems or problems that occur in nature. I should say, and because of the nature, because of the kinds of problems I study, I got to talk to many scientists in other fields. So I got to collaborate with biologists and chemists and physicists and other people in engineering. And so I find it a lot of fun.
Physics, and then especially I know dynamics is a notoriously hard subject for high schoolers to learn. It often comes in play when it comes to a lot of majors. How do you suggest high schoolers kind of like begin to learn these things? And Like, what steps can they take to become better students?
Well, I think there are dynamics all around you. If you like sports, you kick soccer balls, you throw footballs with a spiral, you might go swimming. They're all diving, gymnastics. There are all kinds of things that have dynamics. So maybe the first thing to ask yourself is, are you curious about anything in the world? Are you curious about how things happen, why things happen, why some people might be able to spin faster than others. I don't know. But I think curiosity for yourself is a great motivator because it gets you asking questions why, and then you have to develop your own understanding by reading books or talking to others. And then at some point, of course, it's challenging because in the physical sciences, we want to explain it mathematically. We want to use mathematical concepts to quantify what takes place. And so there you have to learn something, you have to learn some algebra, and then you have to learn some calculus, and you have to learn the language in which nature is written, to quote Galileo. And if you're curious about something, you'll be happy learning. It'll be a great, and then
Yeah.
you'll try to see both sides of it. So it's challenging because it's like learning a language. You have to learn to construct some of these ideas, both with physical principles, if it's dynamics, typically Newton's laws, and what that means physically. And then how do you translate that into mathematical concepts? And we all learn that at different speeds. Some people will feel more comfortable with the physical ideas and then get some of the math. Some people are very comfortable with the math and they try to then have to learn how to apply it to physical problems. But
Yeah,
I
yeah.
was fortunate to feel comfortable with math, at least math as it's used in applications when I was in college, and I learned the physical side after. And over the years, I find the physical side much more interesting. Oh, well, that's probably wrong. I find the physical side very interesting, and I often want to understand.
What other skills can high schoolers begin to develop? Like, even without a wet lab, what steps can they take to get into research?
There are a variety of things you can do at home. If you find it interesting, you now carry in your a phone that can take video, and you can learn to download it and do some image processing with software. You can do things at home that you couldn't dream of, even in some things you had trouble doing in a lab 25 years ago. So there's some things you could probably create for yourself. But I think first it comes from asking questions. What are you interested in? Do you want to build a robot? Do you want to do something in basic research? Do you want to 3D print a classic experiment from physics? You can do that now too, and sometimes that's fascinating. If you like history, that's how I got into things. I liked history, and I found I love to read about the history of science and engineering. 3D print, one of the classic experiments. People actually upload some of that, I think, to the web now.
Oh, wow.
Think about it for yourself, talk about it with your friends. I don't know. There are probably a number of things you could create that you might find fun to do. It sort of depends on what drives you, what you find most interesting. You and your colleagues have to do that, have to decide what that is.
Yeah.
But there are many things you can do with your iPhone and a computer and stuff like that, little image processing.
Is if you're to hire a high schooler in your lab, what type of traits are you looking for? Because I know that professors have like an influx of people trying to get into their lab, but what would make someone stand out to you?
I think when I want to work with people, I'm interested in working with kind people who are curious and who are interested in learning, because many of us are always learning. I'm not looking for someone that necessarily knows something, because lots of us, when we start things, don't know anything. So I think I'm more attracted to the idea that people are curious and interested in learning than anything else.
Yeah, thank you so much for your time today. Have a great day.